So our next speaker is Muhammad Zain Bin Riaz. He's from University of Wollongong, Australia. The topic of his presentation is laboratory measurement of velocity and hydrodynamic forces over coarse fixed rough bed. I will request Dr. Zain Bin Riaz to share his presentation. Thank you.
So good morning, good afternoon, and good evening, everyone from different part of the world. So Professor Dr. Granmabi, are you able to see my presentation?
Yes, sure.
Okay, let's start. So basically the today topic of my presentation is mechanism of sediment transport too hard for Einstein. So I want to thank the organizer to give me opportunity to share my interest on this fascinating topic. So by seeing the photo of the Einstein on the screen, Hans Albert Einstein, the son of the Albert Einstein, was the pioneer of the sediment transport. So the story goes when the Hans Albert was asking to his father what he should pursue and told him he want to study sediment transport and its modeling and his father said it's much too difficult. This is from the man who brought us to relativity. If you see all the existing formulas of sediment transport in hydraulics, starting from Einstein to present researcher and very commonly used shield criteria, all are based on horizontal velocity or shear force. So here's a brief outline of my presentation. For the next 8 to 9 minutes, I will be talking about the importance of vertical velocity and the force in the sediment transport, which with brief background in relation to the past studies, how it has been taken care in the past, and which part of the world has not been studied. And I will talk about a smart physical methodology which I have used to achieve my research goal. So the focus of this talk is about mechanism of sediment transport in highly transient, extremely turbulent flow motion. So the positive or negative surge is a phenomena in which the leading edge of the incoming wall of water forms a wave as shown in left side photo. On the left, we can see approximately 1 meter height wall of water moving and which will continue to move for several kilometers. So on the other hand, positive can be generated in the forms of wave and rapidly unsteady as shown in right side. So what are we up against on the coast? Well, there are very strong natural forces that are hitting the coast, such as waves and currents, and usually the shoreline will respond with an active morphology. As a consequences of this, we have typical problems such as coastal flooding and coastal erosion that can be very problematic when there are activities or peoples that are located at the coast. So in the end, all this is related to sediment transport. Today, the focus of my talk is around the breaking waves, velocities, and forces at different stages of the breaking wave and how it affects the particle motion. So sediment transport movement of solid particle typically due to the contribution of the gravity and fluid motion movement in the rivers due to current and tides. Some field observation and physical modeling highlighted that sediment transport incipient motion is likely to occur only due to longitudinal pressure gradient introduced by free stream velocity gradient. So almost all the previous studies carried out in steady, unsteady, and extremely turbulent flow like tidal bore ignore the vertical motion or vertical force except for the recent theoretical research of Yang, who showed the importance of vertical diving force and how they are affecting sediment transport. So the parameter to express the vertical diving force could be pressure, vertical velocity, and vertical hydraulic gradient in sediment layer. So in figure, during wave passing is negative sign showing dominant downward velocity where the particle become heavier and deposited in this zone, whereas the region with the positive sign showing upward vertical velocity due to which severe erosion should be occur. So still there is no physical evidence available which show the importance of vertical diving forces role in sediment transport. So the current study investigate the mechanism of incipient motion of sediment transport under propagation of the breaking wave. The main aim of this study is to provide a quantitative description of the characteristics of the simulating features in incipient motion during tidal bore propagation, such as fluctuating forces and velocities, and to quantify the influence of vertical force variation on sediment initiation. Most importantly, verification of current study experimental setup with previous studies. So this is a longitudinal cross-section of smart laboratory model. From right to left, initial flow is moving, and by suddenly closure of the downstream tinter gate, a wave comes from left to right. For all the experiment, a highly sensitive force sensor was used to measure the force, and ultrasonic displacement meter to measure the continuous water depth over the fixed probe. A high efficiency camera was fixed just downstream of the target sphere to record the particle movement at movable bed experiment. And then the synchronized output of DAQ system was sent to the computer in the lab view for further analysis. So the bottom left photo is showing fixed force sensor with the target sphere in the flume. Right corner photo is showing LDA system and install ultrasonic displacement meter over the target sphere. For all observation, the initial flow condition was same and different tidal waves were generated by the controlling downstream tinter gate opening. So the tidal bore was divided into 3 points. 1 point starting from smooth rise in the free water surface, point 2 roller toe, and point 3 is the peak of first wave crest. So top left photo is showing force balance in horizontal and vertical direction and a schematic view of the breaking bore. To check the consistency of the experimental setup, at a single measuring point, same run was repeated for 25 times, shown in bottom left graph. So it is very simple phenomena. It is extremely turbulent and three-dimensional phenomena which are not dealing here. So if it always very rapid process. So the left bottom graph is showing the variation of water depth measured in the laboratory. You can see a very rapid increase in water depth in time span of less than 1 second. So the right graph is showing the comparison between measured drag force with estimated drag force by Hizri and Jensen beneath breaking board with Froude number 1.4. So both are in very good agreement. So this confirms the applicability of sensitive force sensor in extremely turbulent flow. So here is a zoom graph of measured velocity component on left in graph A and the force component on right in graph B. So the strong longitudinal deceleration and the negative vertical velocity were linked in the propagation of the bore roller for a short period as shown in left graph. So the right graph is showing the horizontal and vertical forces during breaking bore measured at 5 mm elevation from the bed. So the left graph showing both drag and lift forces acting on particle in the negative direction due to flow reversal through transient recirculation and the sudden increase in free water surface at the arrival of breaking bore. So the findings suggest that the lift force and the roller toe has an important role in the incipient motion of the particles. So two different phenomena, or you can say that two different trends of the forces were observed. So stage one was the smooth rise of free water surface to roller toe, while roller toe to peak of the first wave crest was stage two. So at stage one, lift force was the predominant force, which was 70 to 80% of the submerged weight of the target sphere. However, behind the bore during stage two, the increase in trend of drag force along the bore had a significant role in maintaining motion and determining its extent. So in the current study, experimentally measured data of forces shows the importance of lift force, which has not been previously reported. From this, we can get the answer of some unclear phenomena like abrupt change in turbidity before the bore, suspension of salt and silt before roller toe of the breaking bore in the field observation. So I think we need to rethink a little bit about this topic because we are likely to fall in our communities. the best thing I can say is we need to total rethink of scientific approaches. So generally, research shows that during the smooth rise of free surface in the breaking bore, the increase in forces indicates the importance of lift force, which is necessary for particle movement and increased particle movement during the passage of roller toe. For the most part, drag force was the main influencing force prompting the incipient of upstream particle motion. So during a breaking bore, the force that cause incipient motion are not only due to the velocity, but also to sudden discontinuity in the free surface. So now with the advanced instrumentation, we are able to challenge Einstein's sediment theory by showing the importance of vertical velocity force or pressure gradient, which was previously ignored, and till today we are unable to predict the nearly exact sediment loads in our field. So for more understanding of this interesting topic, you can download recently published article related to today's topic. Last but not least, I want to say special thanks to University of Wollongong and Higher Education Commission Pakistan for joint scholarship, and Gavin Bishop and Peter Henard for their laboratory assistant. So ladies and gentlemen, thank you very much for listening. If you have any questions, you can please contact me on my email, which is shown in the bottom left corner of the slide. Thank you.
Thank you very much, Engineer Zain, for comprehensive presentation on sediment study in the laboratory.